All right. In the first part that you did last night, all you had to do was work on your amplitude. If you notice, when we set this up, all of these frequencies were 1, which means that you do 1 full cycle in 2 pi. I think what they were doing here was, here's your frequency 1 in 2 pi. It's not 1 divided by 2 pi the way they wrote this. It's 1 frequency in 2 pi. And therefore your period, 2 pi over b, becomes 2 pi over 1 or 2 pi. If you think about it in degrees, it's probably easier to catch this. If I think 360 divided by 1, it takes me 360. How many degrees in your circle? 360. So once I complete 1 cycle in my circle, I get 1 cycle on my graph. So the 360 is probably a little bit easier to get a grip on. Now, when we do this, here is your regular sine curve. I'll do it in the same colors. Here's your regular sine curve. Remember your sine goes 0, 1, 0, negative 1, 0. I'm following your whole 360 things. 1, 0, 0, 1, negative 1, 0, 0, negative 1. How many of you were able to graph off your quadrants like this? Oh, let me rephrase myself here. How many of you actually followed this pattern to get the graph?
I used it for the normal one, but not for the
The amplitudes, all you changed was your amplitude there.
So okay.
Yeah, you're still the same right now. You're still the 0, 1, 0, negative 1, 0.
I'll change if the number is after the...
If it's by the b.
Yes.
Yes. Now, so you start. You come around your unit circle and you open it up into your graph. You unravel your circle. Your amplitude here is 1. Okay? When it goes to 0.5, so therefore your range, let's do your range for this. Your range is negative 1 to 1. When it goes to 0.5, take the range and multiply it by 0.5. This is like your dilation, both pieces. So now you're going from negative 0.5 to 0.5. Do you see what we just did? We just made it half of your 1. So up to half, but you're still going 0. Instead of 1, a half, 0, negative a half, 0. You still have the same way we're going to graph your sine curve because we still have a frequency of 1. Okay, now the third one had a dilation of up to 3. So take your negative 1 to 1 and multiply it by 3. So you're negative 3 to 3. Those are your mins and your maxes. When we sketch, we just sketch your mins, your maxes, and your zeros. Where do you find your zeros on these graphs?
At 0.
At the 0, at when y is 0, at
So
your
it's 0
x-axis.
and 1.
Yep, in this case, yep. So we're looking for our zeros and our maxes and our mins. Once we graph those 5 points, we have your graph. We don't have to take, like in Algebra 2, we separated everything by degrees and angles, and you have to plot all the little points. Our basic sketch is your zeros, where it crosses the x-axis, and your mins and your maxes. And your zeros, when we translate, will be the same. We'll just have to translate the axis with us. So we multiplied everything by 3. 0 times 3 is still 0. 0, 3, 0, negative 3, 0. You could take this guy and just multiply all of these by 3. 0, 3, 0, negative 3, 0. And that's the pattern that you follow. Your amplitude just changes the height of this. Okay? It's this piece right in here. And we do the same for your cosine curve. Your cosine curve follows your y values. 1, 0, negative 1, 0, 1. And that gives us a complete cycle. So 1, 0, negative 1, 0, 1. There's your cosine curve. Now, that has an amplitude of 1, that has a frequency of 1. That means it takes me 360 degrees. I go all the way around my unit circle to make one, oh, thank you, to make one complete cycle, right? To go all the way around my unit circle, which is 360 degrees. Was it done?
Yes.
Now, I come here and I say 2. A 2 here. So they're in the red. The 2 dilates this. Okay, take it out. I'll take it one sec. So if you want, you can multiply all these guys by 2. 2, 0, negative 2, 0, 2. And follow that all the way through. Here's your quadrants. At the 0, you're 2. At the 90, you're 0. At the 180, you're negative 1. At the 270, you're 0. At the 360, you're back to 1. So here, sorry, 2 actually. 2, because we amplified it. So just keep following this one. At the 1/3, again, your frequencies are 1. I think they meant this as 1 in 2 pi cycles. The 0.3, just multiply all those things by 0.3. It's about 1/3. So you're a little bit less than a half. You can't get exact, I understand, but you can just come in the ballpark. In other words, don't put it up here. Put it, in perspective, so it would be down there. So that's all. Just keep it where like you think 1/3 is. Probably, a little below the half. And follow your pattern all the way through. Okay? So what we did last night was just change amplitudes. Good? Everybody okay with that?
What are we doing today?
We're changing frequencies.
Hey.
We're phase shifting. We're having lots of fun.
Lots of fun.
Lots of fun.
I love fun.
There you go. Now, did anybody try putting this in your calculator?
Yeah.
Okay.
I did the whole thing on the
You did?
I did the other. I did the backside and
Okay. Now, this works fine in your calculator until we go change your frequency. So, your frequency, you had no problems right here because your scale was every 90. Because isn't that where your
I did
quadrants
that.
are? These are radians.
But I did that.
Okay, let me explain the difference between the radians and the degrees. When you put your calculator in radians and you do zoom trig, it converts your 2 pi to a decimal value. It multiplies 2 by 3.14, blah, blah, blah. This guy here, this was your scale. Your scale said pi over 2 for 90. It does 3.14 divided by 2. Now, in your table, if you're in radians, all your measurements are in radians. Like pi, where B180 says 3.14. So you really kind of have to watch the radians in your table. If you do it in degrees, it makes more sense because 0, 30 degrees, 45 degrees, you spot the degree. I'm going to pull up the calculator in another minute or two, and we'll take a look at both ways. This guy right here is the one that you want to watch, is the scale. That, when your frequency is 1, is your quadrants. What are the quadrants I have to go through? I have to go through 4 of them, 360 divided by 4. So we're going to play with this a little bit when we get to that point. And you can graph them, but I'd like you to be able to sketch without your calculators. Use the quadrant angles. Now, for sine, we're going to go through your 0, 1, 0, negative 1, 0. For cosine, 1, 0, negative 1, 0, 1. That's your 4 quadrants, and it brings us back to the original. Notice, oops, I'm on the original ones you did for homework, sorry. I'm going to be here. Notice this time around, your amplitudes are all 1, but your frequencies are changing. So this guy tells me I have a frequency of 1. That's my normal sine curve. 0, 1, 0, negative 1, 0. So I come to my curve and I start 0, 1, 0. This is my basic sine curve. Okay, and you know it goes -2. This is the graphing window that I was talking about yesterday. Sometimes you see from 0 to 2 pi, sometimes you see -2 pi to 2 pi. That's your graphing window. Your domain for this sine curve is still all real numbers. What's your range for this sine curve? -1 to 1. Good. And we're not going to change that. Close brackets. Good. We're not going to change that because we're keeping your amplitude at 1. What we're changing is this guy in here. I want you to take this 3 and make it a 2. We'll do the 3 later. But I want you to make it a 2. I want to do the 2 first.
Make it 2 times before it
Yeah.
gets to the
Yeah.
next
2 times.
0.
And then we'll do the 3 in a minute. But I want you to catch the 2 first. Now, Anita just told us, doesn't my frequency now say I need 2 complete cycles in 360 degrees? So therefore, if I need 2 complete cycles in 360, how much does it take to complete 1 full cycle? 180. So at the 180, I'm going to put a mark. How many quadrants do I go through on my unit circle to make 1 cycle? 4. This is what's important. If we said 360 divided by 2, your cycle, this is your period, is 180 degrees. At that 180 degrees, you need 4 quadrants. So you need to say period divided by 4. This gives you your quadrants. So 180 divided by 4 gives me every 45 degrees. Now, on your graph, this is easy also, because we're our original ones divided into 4 quadrants, right? I need to make 4 quadrants right in here. So I start with my half, and I take half of my halves. Doesn't that give me every 45 degrees?
Yeah.
See it? I need 4 quadrants to make a complete cycle. I need to put 2 cycles in here. So I do the same to this one. I cut it in half, and I cut these in half. So now I will go through 2 full circles in this. So I will say 0, 1, 0, -1, 0. Isn't that 1 curve? Right? And I need another one. 0, 1, 0, -1, 0. And there's my 2 cycles in 2 pi. So when we say 2 pi over b, that would be 2 pi over 2. So was it my period pi, which is 180? Right? It still makes in radians. Degrees kind of makes more sense to us, because then we take those degrees and we go around 360 and divide that by 4. You can also take your pi and divide that by 4. This is what gives us our quadrants. That's what lets us follow the 0, 1, -1, 0 routine. Now, this last one has our frequency at 0.5, which is 1/2. What does that mean? What do they want when they say 1/2 or for a frequency? Yeah.
Pushes and stuff.
Yeah. Half of my curve in
What time?
360, right? So if half of my curve goes in 360, how much does it take me to complete the other half?
Another 360.
Another 360. So what would my period be? 360 times 2, 720, or 4 pi. So let's take a look at this. If I do 2 pi divided by 0.5, 2 pi divided by 1/2 says keep, change, flip. Isn't that 4 pi? Isn't that 720? But sometimes it's easier to think it out. If I do half my curve in 360, I need another 360 to do the other half. Half my curve in 2 pi, give me another 2 pi. Make it 4 pi is my period. So now, if 720, it takes me to get through 1 cycle, how many quadrants do I have to go through in my circle? 4. So I divide by 4. Every 180 degrees is a mark that I trace. So at the 180, at the 360, if I kept on going, I'd do 2 more to make a full cycle. So I start with 0, 1, 0. And if I kept on going, -1, 0, somewhere along that line, right, if I extended that. So here is half of my sine curve. Half. Frequency, half. You did half of your curve in 2 pi, you need another 2 pi to complete the other side of it. If they gave us the negative area, it kind of makes more sense because if we extended this down, you would literally see the other one come back up. You'd see the other half of your sine curve. And it depends which part they give you.
Can you fill in the chart?
Sure. So for the first one, we were green, right? Our amplitudes are all 1. Go for your frequency first. The frequency is this guy, the B. The period is 2 pi over B. So B here is 1, B here is 2, and B here is 0.5. Now I want to know how long does it take to complete one curve. So 360 or 2 pi, whichever one you want to call it, 180 or pi. And this guy, good, or 4 pi. Good. Good. Okay, so when we change the frequency, that changes your graph horizontally. Watch what happens. When we took the half, did I stretch out my curve or did I compress my curve? You stretched it out. So when you have a B that is less than 1, that's a fraction. It's actually going to do a stretch. You're not making a full curve yet, so you're stretching. When I have a whole number, I'm compressing. I'm shrinking my graph. It kind of works a little different. So I gave you that thing with the transformations yesterday for trig, because your trigs kind of work a little bit different. But I always find in trig, look at your graph and explain what you see. You see this one stretched out, that's a stretch. Horizontally, like an accordion. We're pulling it out. You're shrinking it down, compressing it. Now your cosine curve works the same way. So your cosine curve says, go around and take your x values, 1, 0, -1, 0, 1. Here's my amplitude of 1, amplitude 1, frequency 1. My period is 360 degrees or 2 pi. So I have a regular curve, 1, 0, -1, 0, 1. It makes the U. Okay? Again, my domain is all real numbers. Even though I'm graphing in this little window, my domain is still all real numbers. Now, change this cosine. Instead of a 2, let's make this guy the 3. I want you to see a 3. I just didn't want to do it on the sign. You just did so. Alright, well you can put another one on there. Put a 3 on here. Sorry. How many curves now do I want to put in here? For the 3. What for this guy? I changed that 2 to a 3. I want 3 cycles in 360.
Divide by 3.
Good. So take 3. Okay. So each curve is going to take me 120 degrees. Now, every 120 degrees, how many quadrants do I have to go through? How many quadrants in my circle? 4. Every 120 degrees, this is your period, yes. But every 120 degrees, I need to go through 4 cycles. So every 30 degrees is going to give me a quadrant placement, right? To follow my 1, 0, -1, 0. Now, let's walk through this first and separate this into 30 degrees. This is 0 to 90, right? So 2 in here. So how many in here? 2. 2 in every one. Okay? Good so far? every 30 degrees we need one. So we're going to start with your 1, then a 0, then a negative 1, then a 0, then a 1. My arm is in my own way here. Ah, did I go to 120 degrees? Which 30 more than 90?
120?
There I am. Aren't I a full cycle at 120 degrees?
Yeah. But you need 2 more cycles, right?
We're going to do it again. So 1, 0, negative 1, 0, 1. Do it again. Right? And 120 and 120 is what? 240. So therefore, if this is 270, shouldn't I be ending 30 degrees short of 270 at 240? Yeah? Let's do it again. 1, 0, negative 1, 0, 1. Did I fit 3 in there? Yeah. So your period was every 120 degrees. If you leave 2 pi divided by 3, 2 pi divided by 3 is 120 degrees. I think the degrees are easier to work in because then I'd have to take 2 pi divided by 3. Divide that by 4, which will give you 2 pi over 12, which reduces to pi over 6, which is your 30 degrees. In your calculator, also easier to work in degrees. So let me just pull up my calculator for a minute here and show you in my calculator. Here's my cosine of x. I'm going to go to a regular Zoom trig. I have my mode in degrees. It's giving me 4 quadrants, right? 1, 0, negative 1, 0, 1. Now, when we look at your window in degrees, I don't know why your calculator does this, but it cuts it short of 360. So let's just change this to negative 360 and positive 360. So it made your scale go every 90, because isn't 90 each quadrant? Right? So now let's graph it. And we find your pattern through this. If I want to look at my table, I only need to go every 90 degrees and see where my max, my mins, and my intercepts are.
Where do you go to your table?
Second window. Second window. Otherwise, what you're going to have is like a 1, 2, 3 because you'd be in a mode from before. So I'm in my degrees. So I want to look at every 90, 0, 90, 180. That's what I'm following when my frequency is 1 and my amplitude is 1, right? Now, watch this. Let's change this guy to 3x, the one we just did, and just graph it. I didn't change your 90 marker. So here's your graph. Watch my finger. 1, 2, 3. If I go to look at my table and I want to graph by my calculator, look what I see. Every 90, I see this. And this might not give me 3 sets of graphs, right? Because here's my 360 right here. I only have 1, 0, negative 1, 0, 1. I only have 1 cycle in 360. But I'm supposed to have 3. So here's what you have to do to your table. You have to come to your table and change your X scale. Your X scale is how big each quadrant is. So if we have 3 cycles, we said 360 divided by 3 gave us 120, right? And we needed 4 quadrants. 120 divided by 4 gave us 30. So if we come down here and we change this guy to 30, we also go to your table, watch, second window, and change this guy right here, the triangle table, to be the same as your scale. So now when I look at it, don't I see all my parts? 1, 0, negative 1, 0, 1. And I'm up to the 120. Then I do it again.
And it goes every 30.
Then it goes every 30.
So in order for it to do that, you have to have both the table and then it would go to go 30.
Yeah, exactly. what you could do is you could run your table every 15 degrees. It's like for everything. You'll get a 30, you'll get a 45. The only thing you won't get is if we do a cycle of 4, because that's like 22 and a half, a weird number. But most of the time, you'll hit it at the 30 or the 45, and if you can ignore the other ones. But if you just remember that you take your period and divide it by 4 to figure out where your quadrants go, just make sure your scale and your change of table has the same reflection in that, so that you'll be able to look at it. For those of you that like to graph with your calculator, I think it's harder, it's more involved in your calculator, but if you like to do that, just remember you have to change your scale. Whichever way you like to graph is fine with me. So, we're okay with this? All right, now, we're going to do one where we do everything together. Do I have time?
4 minutes.
4 minutes. Okay. Let's take this one. This is an easy one. What change do you see first? The amplitude. Amplitude is changing. What's happening to your amplitude?
Increase by 2.
It's increased by a factor of 2. So if this is my pattern for my sine, I want to multiply everybody by 2. Okay. What else do you see? 0.5. What does that represent?
Frequency.
Your frequency. So what does that mean to me, 0.5 frequency?
It's going to make it wider.
It's gonna be 2 but every 0.5.
No.
But it's going to stretch it out.
It's going to stretch
So
out your
Oh,
pattern.
it only goes over half of your curve.
360, I'm going to have half of my curve.
So it takes 720 to make
Take 720 to make my whole curve. So if my period is going to be 720, you just figured it out by doing 2 pi over that. I'm going to divide this in 4. Every 180 degrees is going to be a quadrant. So 0, here's my 180, there's my 360. So let's follow this row. 0, 2, 0. Here's half of my curve in 360. The other one is going to be out here somewhere. I got to bring it out here another 320 degrees, don't I? To make the rest of it. And I've got half of my curve in 360.
So the period would be 720.
720. It's easier to think of this in degrees because what happens is your circle is based on 360 degrees. And if you don't think of it in degrees, sometimes you miss your quadrants. Like, well, how do I set up my quadrants? If you just remember to take your period and divide it by 4, then you'll get all your quadrants. Okay, so for homework, I'm giving you this packet, but you can cross off the last 3 columns. Cross off the last 3 in this packet. There's not one. Cool. Cross off your last 3 with your numbers 55, 63, 65. You might have some trouble with the phase shift.
That's probably how it is.
Like the first view, it just tells you to find the amplitude, period, frequency. Just use your formulas. You know, use your formula for that. And if I do take a quiz, make sure I have it by Monday or the next day we meet here.
What's the period again?
2 pi over b or 360 over b.
What library? Class.
No.
Where you going?
These are frequencies.
I'm about to go to get on a ride home right now.